In the second part of 3.6, we're looking at inverse variation. So just a reminder, in the last 3.6.1, we looked at direct variation, which is in that blue box, and that's y equals kx, or varies directly, or y is directly proportional to x. And graphically, that looks like a straight line that goes to the origin. That could have a slope of k, and so something like that. Whereas inverse, also direct variation usually refers to something where as x increases, y increases. Whereas inverse variation is designed to, let me get my pen, model something where y is decreasing as x is increasing, and that is modeled with the variable in the denominator. So that graph looks more like this, where k again is still the constant of variation or the constant of proportionality. A lot of these things are very similar, so I wanted to put these two definitions side by side. Notice a lot of the wording is the same, and the thing that changes is that x is now in the denominator, and the relationship is now as x increases, so as we go from left to right, the y is decreasing. So that's inversely proportional, or y varies inversely with x, or y is inversely proportional to x, or y equals k over x. All right, so in the last section we looked at the s varies directly with t, and we wrote this equation. That was a direct variation. And in this section, this 3.6.2, inverse variation, so if I see p varies inversely with r squared, so that's like this sentence right here, except with the r squared, then that tells me p varies inversely with r squared, so r squared is in the denominator. So that is the inverse of r. I mean, this is r squared, then the inverse of that is this. So that's where it gets its name. Okay, so let's look at the next little problem set. So if I have the equation, well, I can set up my equation here. T varies inversely with s, so s is in the denominator, and I have my constant of variation in the numerator. I can solve for k with one ordered pair, because I know it's something like this, and I just need to find the 1 point on there, and that's going to give me the k. So I have 1 point where t equals 2.4, then s equals 8. And now I can solve for k by multiplying both sides by 8. So that's 2.4 times 8 is going to give me k. So 2.4 times 8. So k equals 19.2. And once I have k, I have this full equation because t and s are both variables. So I just replaced the k with the constant I just found, and there's my equation to describe this variation.